Good afternoon. My name is Troy Talent. I'll be representing the yellow team, presenting the spray paint booth pressure control system. The other members are Garrett Mitchell, Daniel Stoker, and Bradley Turner. Outline of what I'll be talking about today is our system background, description, the SSOC results, our step function results, frequency response, our relay feedback, the root locus theory and plot, and then the proportional feedback control will be the emphasis with the results of that, and then a conclusion. Here's a schematic. This is our SSOC curve. Our operating range is from 35% to 100%, which is 1 centimeter H2O to 13 centimeters H2O. From about 6 centimeters to, actually 1 to 6, the slope is 0.12 centimeters H2O per percent. And from 6 centimeters to 13 centimeters, it's about 0.2 centimeters H2O per percent. This is what I just said. Our line's not really linear on that SSOC. It's partly linear from those two regions I just told you about. This is the 4 to 7 centimeters H2O range. This is Daniel's range. This is our MOV plots over each other. This is how we found from our sine frequency response, how we found our KCU and our FU, which we got from minus 180. The line goes up all the way to where it crosses this plot right here, and your FU is about 2 hertz. And our gain is where this first point is right here, over to the amplitude ratio. So 0.21. KCU is 1 over that amplitude ratio right there, so about 1 over 0.015 or so, which is 87% per centimeter H2O. These are our results from the sine frequency response. For that region we just looked at, the gain is 0.21, our order was 1.3, the FU was 2 hertz, KCU was 87, tau was 2.7, and our T0 was 0.4 seconds. And for my range of 10 to 13 centimeters H2O, 90 to 100%, my gain was 0.28, my order was 1.1, my FU was 1.6 hertz, control gain was 33 centimeter H2O, tau was 2.1 seconds, and my T0 was 0.22 seconds. This is our Bodie plots. Daniels and I graphed over each other. We have our model over our experimental data points. This is Daniel's region, and this is mine. You can see the line goes almost directly through. This is for amplitude ratio. For the phase angle, same thing. Daniel's region and my region. Line trying to hit this point for on our model numbers. And these are our results from that. And they slightly are different from the sine frequency response from the experimental data we had. Our gain for the 55 to 70% range was 0.17. Our T0 was 0.13 seconds. Our tau was 1.5 seconds. FU was 2 hertz. And KCU was 87% centimeter H2O. And for my range, K was 0.28. And T0 was 0.08 seconds, which is lower than the sine frequency response gave us. And my tau was 1.1 seconds. FU is 1.6 hertz, and my KCU was 33% centimeters H2O. This is the relay feedback. This was from the 7 to 10 centimeters H2O range. We got our KCU by taking our change in C divided by our change in M from the floor, the ceiling to the floor, times 4 pi, 4 over pi. And then we got our period T. Our results for 35 to 50%, we had K ultimate control gain of 27% centimeter H2O and ultimate frequency of 1.1 hertz. And for 75 to 85%, we got KCU is 30 and ultimate frequency is 1.5 hertz. And there's a feedback control diagram and our transfer function, or our closed loop transfer function. And here's our first root locus diagram from the 1 to 4 centimeter H2O range. And those in the corner we have our what we use to calculate our root locus model. First one is, I'll go over all these numbers in a table we got at the end, but this is this range. This is Daniel's 4 to 7 centimeters H2O. Same thing. Numbers here calculated. These came from the Bode plots. The others came from the FOP parameters from step up and step down. This is for the 7 to 10 centimeters H2O range. Same thing. And then my range, 10 to 13. Mine came from the Bode too. And then here's a table of all those values. So, and that's supposed to be, no, that's right. Okay, so for Brad's range 1 to 4, we got 17 for the critical decay, 30 at the 1/500th decay, 61 at the 1/10th, 79 at the quarter decay, and 120 for your ultimate. For the 4 to 7 centimeter H2O range, we have 11 for the ultimate, for the critical decay, 21 for the 1/500th, 42 for the 1/10th, 56 for the quarter decay, and 85 for the ultimate. And for 7 to 10, 16, 27 for the 1/500th, 54, 71, 110, and then mine, 9, 16, 32, 42, and 64 for the ultimate control. Basically, this next slide is the same thing, just showing you what we use for our predicted values for our proportional controller. Same numbers in the last table, just again in a different table. And then so what I did was we ran, this is from the 4 to 7 centimeters H2O range. We ran predicted ones, and then we found the KCs by experimental values to see what the difference was. So for this first one, we got our critical decay, and then we got a decay ratio of 0 and an offset of 0.8. So his region right here came up and didn't ever hit the set point. And just basically, we have a lot of noise in our system, so none of ours ever looked straight, really. So the next one, for the 1/500th decay, you got your first peak here to the set point, and then here to here. So your decay ratio is like, you said it was 0, but 1/500 basically, and an offset of 0.5. This is 1/10th. We got a 0.36 and a 0.3 offset. Close, but not right for the predicted. For our quarter decay, we got 0.57 and 0.4 is that's not right, but this was just the predicted value. And then the last one for the ultimate is kind of you can see it's kind of oscillating at the same height every time. So this is almost the ultimate K2. K ratio of 0.98 and offset of 1. And then here's our actual experimentally found ones. So our critical decay, we said it was the same at 11 for KCU. For this one, it was 21, so the same as the first one you saw for the 1/500th decay. We had the big first peak, and the second peak was a lot smaller. And for our 1/10th, we said this was different. had a table at the end. It'll tell us, I don't remember right off the top of my head. But, see, it goes 1/10 offset of 0.2. Decay ratio on this one, 0.24 for quarter decay. Offset of approximately 0.5 centimeters H2O. And for our ultimate controller gain, we used about 85, I believe, for the KC, which is almost the same as the root locus for Daniel. Here's a table for the results for Brad's section and for Daniel's for the 1 to 4 centimeters H2O. So all of our values were oscillatory, we said. Brad's found KC critical decay was 17, 1/500 was 25, 1/10 was 35, and his 1/4 was 50, his KC was 70. And these are all a lot different from the root locus for Brad. And then for Daniel's, we went through all those, but our 1/10 was 26, and our quarter decay was 32 for his, and 85 for the ultimate. And there's the settling time, which were all pretty minimal for our system. And then 7 to 10 centimeters H2O. These are Garrett's. They were very different. Garrett had very high numbers, as Brad did, but he had a lot lower KCs here. He had 11 for his ultimate critical, 13 for his 1/500, 17 for his 1/10. For his quarter decay, he had 20, and 35 for his ultimate control gain. And then mine were somewhat close to my root locus. Well, we ran several experiments on these, and we run the same number over again, and we get different values. So it was kind of hard to determine what exactly was our 1/10 decay and our 1/500. The ultimate and the critical were pretty easy, but the rest were pretty hard and fuzzy for us. So here's all the comparisons. You can see Brad's were different. His root locuses were much higher for his ultimate quarter and 1/10. Same with Garrett's, 7 to 10 centimeters H2O. He had root locus values that were much higher, 107 compared to 35 for his ultimate controller gain. But Daniel's and I's were very close. Well, not really very close, but we changed our quarter and our 1/10 and our 1/500 decay. In conclusion, KC values found using the root locus were proved to be incorrect by the experiments for all the regions, especially for the 1 to 4 centimeters H2O and for the 7 to 10 centimeters H2O. They were usually lower than the predicted values. The KC values were usually lower, and the root locus was really not a reliable source for the KC values. And then for the previous conclusions, our 35 to 50% range and our 75 to 85% range, the KC values agreed because the parameters used were from the step experiment results. I said that earlier. And then from the 55 to the 70 and the 90 to 100, the KC values agreed because the parameters used were from the sine experiment results. And to stay under damped at all power levels, we recommend that you stay within the range of 17 to 64% centimeters